Good day, Grade 6 learners. Welcome to our Lesson 4. Mathematics 6. Term 1, Week 1, Session or Day 3. Our topic for today is translation, reflection and rotation with shapes. Please don't forget to like, share and subscribe. Thank you. Here are the basis of our lesson for today. A. Content standards. The learners should have knowledge and understanding of the tessellation of shapes, translation, reflection, and rotation with shapes. B. Performance standards. By the end of the quarter, the learners are able to tessellate a surface using different shapes. C. Learning competencies and objectives 1. Explore whether or not a shape tessellates. Tessellations. Define tessellation and explore whether or not a shape tessellates. Illustrate translation, reflection, and rotation with shapes. Tessellate with translated, reflected, and rotated figures, shapes 2. Draw resulting images of shapes that undergo translation, reflection, and rotation. Translation, reflection, and rotation with shapes. 3. Tessellate a surface using different shapes, including triangles, squares, and rectangles. Developing and deepening understanding. Activity 3. Symmetry challenge. Finding the mirror image. Look at the object. Which image on the right is its perfect mirror reflection of symmetry? Select the matching pair. Find 4 pairs. In a vertical mirror reflection, up and down stay the same. Left and right are reversed. Explicitation. Activity 4. Look at the figure. Only half is drawn. Using your knowledge of lines of symmetry, complete the other half. When you were doing activity 4, you had to draw the missing half. To get it perfect every time, follow these 3 golden rules. Count the grid squares. If a line starts 3 squares away from the red line on the left, your drawing must start exactly 3 squares away on the right. Check the points. Find the corners, or points, of the shape. Mark them on the empty side first, then connect the dots. The flip rule. Remember, if a part of the house, like the chimney, is on the far left, it will appear on the far right of the new drawing. Reflection can also be called flip. Reflection is done when the figure is flipped and produces its mirror image, which is being flipped or reflected across a line called the mirror line. This mirror line is also the line of symmetry. The resulting figure, shape must be of the same size and alignment. Translation. Translation can also be called slide. Translation is done when the figure slides or moves from one place to another. The resulting figure, shape must be of the same size, but there is change in the direction. Rotation. Rotation can also be called turn. Rotation is done by turning or rotating the figure around a fixed point, or center. The rotation can be done either clockwise or counterclockwise. Worked example. Example 1. Reflection. The figure reflected across a vertical line of symmetry. Example 2. Reflection. The figure reflected across a horizontal line of symmetry. Example 3. Draw the missing figures so each is a reflection of the other across the vertical and horizontal lines of symmetries. Alright class, look at our new slide. This is what we call symmetry across two axes. Before, we only had one mirror, but now we have two. Imagine the green dashed lines are magic mirrors. We have the y-axis, the vertical one standing up, and the x-axis, the horizontal one lying down. Here is how we understand this for our activity. 1. The original shape, quadrant I. This is our starting point in the top left. It's an orange shape with one rounded corner at the top left. Everything we draw will be based on this specific shape. 2. Vertical reflection. Mirror on the y-axis. When the shape looks into the standing mirror, y-axis, it reflects to the right side. What changes? The left and right side swap places. What stays the same? The height, top and bottom, remains the same. If the rounded corner was on the outside, it should still face the outside in your drawing. 3. Horizontal reflection. Mirror on the x-axis. Now, imagine the mirror is on the floor, x-axis. We call this a water reflection. What changes? The top goes to the bottom. The shape is now upside down. What stays the same? The left and right positions do not swap. In our previous slides, we talked about reflection, mirrors, where the shape flips. But look closely at these two triangles, did they flip? No. Here is how to explain this to your seatmate. 1. What is translation? In geometry, a translation is just a fancy word for a slide. Imagine you have a cutout of this triangle on your desk and you simply push it to the right without turning it or flipping it over. That is a translation. 2. The identical rule. Notice that the two triangles are exactly the same. The pointing side is still facing the right. The tall side is still on the left. The size hasn't changed at all. 3. The green arrow, the vector. That dotted green arrow shows us the path of the move. It tells us two things. Direction, we moved to the right. Distance, it shows us exactly how far the triangle traveled. Imagine you are in an elevator. When the elevator moves from the 5th floor to the 1st floor, do you flip upside down? No, you stay exactly the same, you just move to a new spot. That is exactly what is happening to our triangle here. 1. The slide rule. In geometry, translation is just a fancy word for a slide. The triangle at the top is our pre-image, the start. The triangle at the bottom is our image, the finish. It didn't flip, and it didn't turn. It just slid straight down. 2. Are they identical? Look at the features of both triangles. Is the tall side still on the left? Yes. Is the pointy end still facing the right? Yes. Is it the same size? Yes. If everything stays the same, it is a translation. 3. The green arrow. See that green dashed arrow? That is our guide. It tells us two very important things. Direction. It tells us we are moving down, vertical. Magnitude, distance. It shows us exactly how many blocks the shape traveled on the grid. Now, we're looking at a specific kind of transformation in geometry called a diagonal translation. That's a big word, but we're going to break it down. Imagine you have your triangle at the top of your paper, and you just want to push it or slide it to a different spot without turning it or flipping it. We call that a slide, or in math, a translation. 1. What is a diagonal translation? Look at the green dashed arrow, we call that a vector. It shows us that the triangle didn't just slide straight to the right, and it didn't just slide straight down. It slid diagonally, like taking a shortcut across the park instead of walking around the perimeter. 2. Are the triangles identical? Notice that the two triangles are exactly the same size and shape. If you were to cut them out, they would fit perfectly on top of each other. The pointing side is still facing right, and the tall side is still on the left. 3. Check your path. See how the path, the green dotted arrow, connects the bottom left point of the top triangle to the exact same bottom left point of the bottom triangle. When you are doing your activity, make sure your vector connects the exact same corresponding point on each shape. We are moving into some pro-level math today. We aren't just sliding shapes anymore. We are using a coordinate translation guide to move them exactly where we want them. Think of this like giving a robot specific GPS coordinates to move a piece of furniture. You have to be very precise. Step 0. The original shape. Every translation starts with a pre-image. Look at our blue triangle on the grid. It has 3 corners, which we call vertices. To move the whole triangle, we just need to move those 3 dots. Step 1. Plotting with the 2, 3 rule. In grade 6, we use a rule to tell us how to slide. Our rule today is 2, 3. The first number, 2, is for the x-axis. Since it's positive, we slide 2 units to the right. The second number, 3, is for the y-axis. Since it's positive, we slide 3 units upward. Look at the top right box in our slide. See those red and green lines? We did that for every single dot. Teacher's tip. Always move over first, then up or down. It's like walking to a building before you take the elevator. Step 2. Connect the points. Once you have your 3 new dots sitting in their new spots, grab your ruler. Connect them to form the new orange triangle. Now, we're going to combine them into one cool move called a glide reflection. Think about how you walk down the hallway. You don't just jump with both feet, right? You move one foot forward, then the other. That natural walking pattern is the perfect example of a glide reflection. The 2-step move. To do a glide reflection, you have to follow 2 specific steps in order. Step 1. The glide translation. Imagine your left foot is on the floor. First, you slide it forward along a straight line. This is the glide part. In our diagram, you can see the top left foot moving across the green dashed arrow. It hasn't changed shape yet, it just moved forward. Step 2. The reflection, the flip. Now, imagine there is a mirror on the floor right next to that foot, the axis of reflection. You take that slid foot and flip it over to the other side of the line. The magic trick. When a left foot reflects across that center line, it actually becomes a right foot. We've already done the glide, the slide, and now it's time for the reflection, the flip. This is where the magic happens and the left foot transforms into a right foot. 1. The mirror line, line of symmetry. See that long black horizontal line with the arrows? That is our line of reflection. Think of it as a long mirror placed flat on the ground. Everything that happens above the line must be copied exactly, but flipped, below the line. 2. The reflect action. Look at the green footprint. That's our intermediate step, the foot after it has slid forward. Notice the red dashed arrow pointing down? That tells us we are moving across the mirror line. The big flip. When we reflect the foot, look at what happens to the toes. On the top foot, the big toe is on the left. But once it flips below the line, the big toe is now on the right. 3. Left foot versus right foot. This is the most important part to remember. A translation, slide, keeps the foot the same, left remains left. A reflection, flip, changes the foot, left becomes a right foot. Because we did both, the final result, the black footprint at the bottom, is now a right foot and it is further ahead than where we started. We've mastered the slide and the flip, but today we're going to learn how to spin. This is called rotation. Imagine you have a piece of paper pinned to a bulletin board with a single thumbtack. If you push the corner of the paper, it swings around that tack. That's exactly what we're doing with this triangle. Step 1. The fixed point, the thumbtack. Before we spin anything, we need to know where our thumbtack is. In this problem, point A is our fixed point, or the center of rotation. Point A will stay exactly where it is while the rest of the triangle moves around it. Step 2. Axis and direction. We need to know which way to spin and how far. Direction. Clockwise, the same way the hands on the classroom clock move. The turn. We are doing a 1/4 turn. If you think of a full circle as 360 degrees, a 1/4 turn is exactly 90 degrees, like the corner of your notebook. 3. Rotating the sides. Look at the side connecting it to B right now. It is lying flat, horizontal. If we spin it 1/4 turn clockwise, that flat line will stand up and become vertical. Notice how the length doesn't change. If side AB was 3 blocks long before, it must be 3 blocks long after the spin. 4. The final rotated figure. Once you've moved side AB and side AC, you just connect the dots to finish your triangle. Alright class, great job on that 1/4 turn. Now, we're going to level up. Look at our new slide. Example 10. This time, we aren't just doing a small nudge. We are rotating triangle ABC by a 1/2 turn clockwise. Point 1. What is a 1/2 turn? Think about a pizza. If you eat a 1/4 of it, you eat in one corner. If you eat 1/2 of it, you eat in the whole top half. In math, a 1/2 turn is exactly 180 degrees. It's like doing a U-turn on your bike. You end up facing the exact opposite direction. Point 2. The pivot point, center of rotation, just like before, point A is our thumbtack. It's the center of rotation. Notice in the solution box that point A stays in the middle, while the rest of the triangle swings all the way around to the other side. Point 3. Observe the opposite effect. Look at the original triangle. The small one at the top, side AB, was pointing to the left. After a 1/2 turn, where is it pointing? That's right, it's pointing to the right. Side BC was pointing up. After the 1/2 turn, it is now pointing down. Teacher's secret. A 180 degrees rotation is special because everything becomes the opposite. Left becomes right, and up becomes down. It's like the triangle is looking at its original self from across the room. For example 11, we're doing something a little different. We've been spinning things clockwise, like a clock, but now we're going to go counterclockwise. That means we're spinning to the left. Think of it like unscrewing a cap from a bottle. Point 1. The new fixed point, point B. Pay close attention. In our earlier examples, we pivoted around point A, but look at the instructions. We are rotating around point B. This means point B is our thumbtack now. It stays exactly where it is, and the rest of the triangle swings around at point 2. The 1/4 turn 90 degrees. A 1/4 turn is a square turn. It makes a perfect L shape from where it started. Imagine the side BA. Right now, it is lying flat on the ground, horizontal. Since we are going counterclockwise, we are going to pull that side up. 3. Watch the transformation. Look at the solution diagram on the left. The original dashed lines. The triangle started lying down. The move, green arrow, we swung the triangle up and to the left. The result, blue shape. Now the triangle is standing tall. Good job today everyone. You listen well and work hard. Keep up the good work. See you next time.